Our observation is that we're really moving from a world where humans are authoring search queries and humans are executing those queries and humans are digesting the results to a world where AI is doing that for us. And if you've used the deep research tools within ChatGPT, Anthropic, Claude, etc., you'll notice they don't only look at one page of blue links. They're actually canvassing hundreds of thousands, if not more, pages of the internet to try to find an answer to your question.
That was Jeff Huber, CEO and co-founder of Chroma, on the paradigm shift we're currently undergoing with respect to search, retrieval, and grounding AI and LLM outputs in, well, reality. Agentic retrieval is one of the major reasons context engineering has become so important.
Context engineering does a few things. Number one, like it is the job today. If you're looking to build a production system, that is the job. Engineer your context window. Prompt engineering is like script kiddie versus context engineering is more like software engineering.
In this conversation, Jeff and I dive into the nitty-gritty of context engineering, but something Jeff has really enlightened me to is what he calls the outer loop of context engineering.
I think this is ultimately the real job of context engineering. One is like setting it up for the first time. And like you create all the pipes, you create all the connectors, and you make sure the agent can use them correctly. The data starts flowing, and that's great. Let's say they could see you to 90% reliability. But for use cases that are non-subject matter expert facing, either internal or to like end users and customers, you need to get to like 99.9, etc. And so I think there's both the machine and then there's the machine that builds the machines. And people are building an AI today. We're very focused on building the machine, but we're not yet focused on building the machine that builds the machines. It's both figuring out what do I put into context this time? That's the inner loop. And then it's how do I get better at context filling over time? And that is the outer loop.
In this episode, I speak with Jeff about the rise of agentic search, about context engineering, the sophisticated evolution of prompt engineering required to build reliable agentic AI systems. We discuss why merely stuffing large context windows is no longer feasible, and how precisely curating high-precision information is key to ensuring accuracy. We talk about the importance of the agent harness, the collection of tools and capabilities an agent can access, and share best practices for builders, such as the importance of hybrid search and why embeddings are not always enough, when to use sub-agents, and in what cases you may need to rip out your agent harnesses when new frontier models are released versus building more well-defined workflows. We also dive into the unsolved challenge of agent evaluation and why focusing on building the outer loop for continuous improvement is paramount for builders. This conversation was a Q&A from a recent cohort of our course Building AI-Powered Applications, which I have the great pleasure to co-teach several times a year with my friend Stefan Krautchik, who works on AI agent infrastructure at Salesforce. Links in the show notes if you're interested. Also, if you enjoy these conversations, please leave us a review and give us 5 stars on your app of choice, and share with your friends and colleagues. I'm your host, Hugo Bown-Anderson, and welcome to Vanishing Gradients. Awesome. Jeff, such a pleasure to have you here for this guest Q&A in our course, man.
Thanks for having me. Glad to be here.
And everyone watching, please do ask questions in Discord in our special guests November 2025 channel. We've actually just had a workshop, Jeff, on, it used to be called something along the lines of embeddings, vector stores and RAG and that type of stuff. We changed the name to information retrieval, search and context engineering. And of course, a lot of the content has changed recently, but I hope we can get into demystifying why we use the terms we do, but also what it really means for builders. I do just want to start, I think everyone has enough context, pun not intended, around what you're up to. But for a bit of background, you studied economics and engineering and left college to start a company, Standard Cyborg, which you were with for 5 or 6 years, which was computer vision systems for prosthetics. Is that correct?
Yeah, most of the details are close enough. Yeah.
Okay, cool. And part of this led to you thinking about the things that you're building today. So I'd love to know the origin story and the motivation behind why you spend your time doing what you do at Chroma.
Sure. Yeah, I'm Jeff. I'm the CEO and co-founder of Chroma's building modern search infrastructure for AI. Some people call that a vector store, vector database. Those terms are also okay. My kind of path here was I've worked now in applied machine learning and developer tools for close to 10 years. And the path to production in machine learning has also always been very challenging. Building a demo is pretty easy, but building something that was like production reliable was always pretty hard. And this is true in building lane detection computer vision systems in 2016. As it turns out, is also true about building RAG chatbots and things of this nature. Demos are easy, but production is hard. And so that was really like the motivating factor behind starting Chroma before the language model boom really came about. We started before ChatGPT. And our goal was to help teams curate the right data to bring to their systems. In so doing, build more reliable systems. We also believed strongly that like latent space was this really important tool to help people build useful stuff. As it turned out, a lot of these bets were very well timed and a little bit of luck, a little bit of skill, and that's where we are today. So now Chroma is downloaded over 8 million times a month. We're the most popular open source solution in our category. We have over 24,000 GitHub stars and growing quickly. We also, as maybe folks on the call have heard, we have a managed cloud service now as well. And we're just continuing to build cool stuff and ship open source software and go from there.
Super cool. And I mean, congrats on everything. Chroma Cloud, among many other things since the last time we spoke. You're also, it's so much great stuff. Something we did in the workshop we just ran is pip install Chroma DB. Who would have thought pip installing a database is something one could do these days?
We were almost the first ones to do that. And the lore there is actually a little bit interesting if you'll entertain the side story. Before ChatGPT came out, there were no AI engineers. It was just machine learning engineers. And machine learning engineers are notoriously incredibly busy and overwhelmed and stressed. And they use Python. And so we realized, well, to get our technology into the hands of these people, we need to like make the time to value so fast. And they're already used to like pip installing stuff. So what if we like had them pip install the database? And that's why we originally did that. We originally built like pip installable search, vector search was for that, like that target audience, if you will. And then I said on the internet that we were like the first database to do pip install. Now it's like really common for people to do pip install. And I was correct that technically SQLite, you can also pip install.
Right.
But apart from SQLite, I think we were the first. So
awesome. And I slightly lied or mischaracterized. We're modern enough to have UV pip installed it today as well.
Hey, there you go. Nice.
Super cool. And also, somewhat recently, we've been talking in the course about using such tools as BM25 even to establish baselines and that type of stuff. It's great to see sparse vector support in Chroma these days as well.
Yeah, we're really excited to bring. We really think that like hybrid search really is the best practice. And it's if you're doing something out of the box and you don't want to think too much at the outset, like what type of tool you should use, hybrid search is probably the best. Lexical and semantic have opposing strengths and weaknesses when it comes to recall and precision. And so using them together usually is the best.
Totally. And as I hope we'll get to, there are lots of different tools and an overwhelming amount, but if you have some form of evaluation to guide what you use and how you build, that can help. But we're here today to talk about context engineering and the rise of agentic search. But there are two terms in there that I'd love. I'm going to make the cardinal sin of any podcaster to ask two questions at once. What's an agent, Jeff? And what is search?
Yeah, what is an agent? That is a hard question. Depends on who you ask. The meme on Twitter recently was like, is an agent a workflow, I believe. So I won't dive into that argument. But I think an agent it's simply, if a language model is a piece of technology, it's a feature, an agent is a benefit. It's a goal, it's task-oriented, uses a language model, obviously, most of the time. Maybe also gives that agent or gives that LLM access to various tools, various environments, to hopefully solve problems for users. And occasionally those can be in a structured workflow, but oftentimes they're not. I think increasingly they're not. Agents, you can give tools to write code, you can give tools to search your data, search the internet, search your databases, etc. And they can get pretty creative at how they mix tools together to solve complicated problems. Yeah, that's, I guess, the agent part. And then we talk about like agentic search. The idea is as opposed to hard coding the RAG, where like the retrieval, where like you stuff the context window with the knowledge of the documents the agent should know about, and you just let it reply. Agentic search is the agent has a tool called search, or many tools that are like search. And the agent can use those and compose those into sequences and compose them together, again, to go and find the relevant information. And that ability to do multi-hop search is almost like a scaling law of search, where the more tokens you spend, the more accurate and the better documents you can find. So agentic search is very powerful. Context engineering comes into play because, as maybe a lot of folks on the call have either experienced directly or read about, all LLMs as we know them today experience context rot, whereas the number of tokens in the context window goes up, agents' performance goes down, and quite precipitously for certain kinds of tasks, in particular those that require high degrees of reasoning and high degrees of attention, so paying attention to a large portion of the context window at once. And so context engineering is basically the goal of like only bringing the relevant information, that high precision information, and then also removing all the distractors as well, because agents can very easily become distracted by irrelevant information, even that we as humans would easily gloss over and ignore. Agents get distracted by it. So context engineering is at this point in time, it seems like the largest point of leverage to building agents that do useful things at a reliable rate. And then, so search and retrieval, in some ways, it's just the same as a classic search. Most people have used maybe other search tools in the past. Put query in, get documents out is the simplest way to think about it. There are some unique parts about vector search, which I will touch on very briefly because I know I'm monologuing a little bit here, which is the data expansion factor. So for example, if you're using the large embedding model from OpenAI, a gigabyte of text can easily turn into 30 gigabytes of vector data. And as everyone on the call probably knows, memory is not exactly inexpensive, and therefore building a system which is cognizant of that and thoughtful about like only putting in vectors and vector search index data into memory when it absolutely needs to be becomes a very important primitive in building a system which is very cost effective. And so that's what both Chroma Distributed, the open source Apache 2 project, and then also Chroma Cloud that uses Chroma Distributed is built all around, is like a series of indexing approaches, which if you want to learn more, they can go to our YouTube channel and subscribe. And there's a whole video on vector indexing that goes into depth about that.
I love that video. And also, I have shared several of your reports, and the videos you do with your reports are wonderful as well.
Thank you.
And some of that's actually some of the homework for this course this week is to take workshop transcripts from this course and generate a gold data set of questions based around your technique. And we didn't watch Kelly's video, but Kelly's video, the 12, 13-minute version of the report, chef's kiss, man. Everyone should check that out as well. And also, thank you from everyone for sponsoring the course and giving everyone $250 of credits to build with Chroma Cloud. It's incredibly thoughtful.
Happy hacking.
There's so much in there. I do want to step back a bit and think, when we're talking about AI search, now we have an LLM with tools doing search. We've been doing search ourselves for ages.
Yeah.
What changes from like Hugo in 2001 learning to Google to an LLM or when I used to ask Jeeves? No, I never asked Jeeves. But what's the difference between human search and AI search, man?
Yeah. Alta Vista, Yahoo, we're really digging up the old memories here. I think that's exactly right. Our observation is that we're really moving from a world where humans are authoring search queries and humans are executing those queries and humans are digesting the results to a world where AI is doing that for us. And if you've used the deep research tools within ChatGPT, Anthropic, Claude, et cetera, you'll notice they don't only look at one page of blue links. They're actually canvassing hundreds of thousands, if not more, pages of the internet to try to find an answer to your question. And in many cases, again, these questions are not, we've all learned how to Google, as you just said. And so we've learned how to use, frankly, you've learned how to use lexical search and DM25 almost and other techniques to like compose the right set of these 4 words in this sequence with this type PDF site org at the end. We kind of all learned like Google's DSL, right, to figure out how to search. And in some ways that was really powerful, but in other ways, not that powerful. You can't go into Google, maybe today now AI mode you can increasingly, right? But like, historically, you couldn't go into Google and type like a really long and complicated query that would require like many pieces of information in order to assemble together. You're only ever doing one query at a time. And now with AI, you're potentially asking the deep research agent to go do a lot of work to help do many queries and assemble a tapestry of information and distill it back to you. And I think what's really exciting to me about this is like actually increasing the kinds of questions that we as humans can ask. And it's decreasing the cost to getting those questions. And so from the systems perspective, what is different is the following. The queries are becoming much more complicated. The number of iterations is going from a single iteration, submit Google search, get back 10 blue links, to many searches, many iterations in a row. And then the hard part is, I think, still what we as an industry are figuring out is like, how do we translate the level of intuition that we as humans have developed about how to search, how to stop searching, when to start searching, how to change strategies, like all of these things that we built an intuition around and have become quite good at just through being citizens of the internet. Like, how do we translate that over to agents? Because they now need to do that heavy lifting for us. So this is like some of the active work that we're doing at Chroma on the research side as a follow-up to Context Rot in our other technical reports, is looking deeply into a lot of these topics.
I love it. And the tools you mentioned, I do have a lot of experience with. I've been using Manus a bunch recently, and I'm fascinated. I love watching Manus and what it will do in terms of how it scales the internet. This is slightly tangential, but the internet seems somewhat built for humans, not built for agents, right? So one example is I've sized 17 feet, and so buying shoes is really tough. So what I did was I got Manus. Previously, I used to have to shop at a shop called Bigfoot. Actually, one shoe salesman told me to take the boxes home instead of the shoes once. So but when I watch Manus find shoes in Sydney my size, it will go around and click on drop downs and that type of stuff. That doesn't seem like an optimized experience, well, for anyone, but it's slightly optimized for humans. I'm wondering your thoughts on the emergence of an internet which is more LLM and agent friendly.
I don't think we know yet exactly how this will play out, because obviously one version of this is like every website has an MCP server, and you can plug shoes.com into your MCP. Inside of the tool call, there's a field called shoe size that we just let the agent rep using that MCP server. And then obviously another version is kind of the computer use agent style headless browser automation where the agent goes and uses the website directly. I think that it's going to take a really long time to get to 100% adoption of any new protocol or technology. And so because of that means that there's also the opposing incentive for any platform that wants to offer very good, very diverse use cases to make their agents very good at computer use, and then only use sort of dedicated protocols or APIs as they become available to increase the speed and the reliability. And so I don't think it's an either or. I think it's a both and. But I suspect that while agents today are still quite slow, not very good at using websites directly, I suspect that will get so much better simply because it is a very RL-able environment. It's very easy to synthetically generate a huge amount of data in that context. Anything where you can synthetically generate large amounts of data, you should assume that machine learning will be able to accomplish pretty readily.
Yeah. We've got a couple of great questions on Discord that I'll get to. One in particular is around large context windows and context rot. So I am interested if we could go back to a bit more about context engineering, how you would explicitly define it and why it's a good term.
Yeah, I mean, the term of art really before context engineering arguably was prompt engineering. I'm sure many of people listening remember this term, and we're all going to be prompt engineers and we're going to craft your prompts. And I think a few things have happened. Number one, AI applications have become much more complicated than a single static system prompt. You have workflows and you have different agents doing different things, and different information at different times, and they reference lots of external information and weave it together. And so prompt as the main task being prompt engineering started to just feel a little overly narrow. Also, prompts increasingly are becoming, the other factor is prompts are increasingly becoming less and less human written. And we're using modern tools like JEPA to do prompt optimization for us. And I think that arguably prompts are also we're going to be meta prompting, not writing prompts. So context engineering became a term, I think, really because people started to understand that you couldn't just yeet a million tokens into the context window and hope and pray that it's going to work. Maybe you can do that for fun, but if you really care about, again, reliable results for end users on user data, you really have to be more thoughtful and discerning about what goes into the context. And agents also get really distracted. Even if you look at an agent, for example, where it made a mistake somewhere previous in its trajectory, and it even recognizes in that point in the trajectory that it was a mistake, right? It says, oh, I tried X didn't work. Okay. You'll find that later in the trajectory, it does it again. And you're you know that you did this wrong, it's right there. And yet it knows that it did it again. And so I guess it points to the fact that really, if you want to get to production reliability with agents for most use cases, you really need to be engineering the context window. And that is your tool to change the behavior of the agent, is by changing what goes into the context. Almost nothing else really matters. Maybe you can fiddle with the temperature on some few of the other LLM settings. It's really all about the context. Now, people are starting to play around with a little bit this term. I hate new terms, but I'll mention it here briefly, which is harness engineering, which is arguably it's not just about the context, it's also about the tools and the environment in which the agent sits. And you give the agent the ability to write code and run code. It seems to get to new emergent capabilities. If it didn't have that tool, it couldn't do. And yeah, we don't need to invent any new terms, but I think, again, context engineering does a few things. Number one, it is the job today. If you're looking to build a production system, that is the job. Engineer your context window. And then number two, I think it also raises the status of the job. Like it becomes a thing you could call yourself almost if you wanted to. You could call yourself a context engineer because that's the job. And it's a really important job. It's a really hard job. And I feel like prompt engineer always had this vibe of like script kiddie, right? It's almost like that equivalent of prompt engineering is like script kiddie versus context engineering is more like software engineering. And this is a really important thing. It's going to be a really important thing, we think, for a long time. And so it's good for humans to get good at it. Let's give it a title which we humans would want to adopt and describe ourselves by that's aspirational. And context engineering, I think, is that term.
Yeah, a lot of that resonates. And I was always uncomfortable with the term prompt engineering, as a lot of us were. I think other people did as well, but I used to call it prompt alchemy. And I'm far more saying context engineering because, as you say, it does feel a lot more like engineering. Of course, it does feel like engineering, but with all the non-determinism and entropy and messiness of the real world and agentic behavior thrown in. And that's something we really try to deal with in this course, which is for data ML people and traditional software engineers, and getting software people really comfortable with kind of the new way to think about the software development lifecycle and rapid iteration is still a big challenge. I am interested, does the term
I could say something on that really quickly.
Yeah, please.
I think that, like, in many ways, building with software, we had the luxury of a very long time of being a very like deterministic system. Unlike the real world, right? Where in the real world, you don't always get the same result every time. In software, it felt like you always get the same result every time. It's very deterministic. Unit tests, wonderful, whatever. And obviously with AI, this is like not the case. So it's almost like building something more in the real world, where building with AI is more like building in the real world, where like you don't quite know if it's going to work until you put it into production. Sometimes I like analogize this to like building like a race car engine. Like you can have a theoretical model of how you think the engine works, but like, you don't actually know how it works until you put it in the car and you like send it around the track and you instrument it and you see how it works. And you notice when it's not working and then iterate on that data. And then obviously in production, when you're actually running the race, you're still instrumenting the engine, looking for ways to optimize it. And I think this is the SDLC looks much different in, I think, an AI native world because of this, where like in the former case, you could fully almost like test the system or model its behavior in the lab, versus with AI, you can't. You got to get it out there into the real world and then let the real world inform you of its strengths and weaknesses.
Yeah, I totally agree. And I love the race car engine analogy. I think it takes it a step towards it. I actually don't say this a lot publicly for a reason that'll become obvious, but I do think of AI systems, I do refer to them as organic or organic-esque in a variety of ways. Sure. I don't like the anthropomorphization of a lot of what happens in our space, which is why I don't say it that often. But I do think in terms of the way we interact with them and the way we introduce them into the world, there is a sense of the organic and not static nature about them as well.
Yes, maybe it's also like, not to opine this too much, but I've also before thought about it as like gardening. Like your job is to curate the environment in which the agent runs.
Totally. Before moving on, I am interested, does the existence of context engineering imply the existence of a context engine?
It might, yeah. So, I mean, context engineering implies the existence of context engineer for sure. Does it imply the existence of a context engine? I think probably also yes. Now, whether or not that ends up just becoming each individual use case and company's own harness for curating context, that might be the case. It's the most likely the case in my mind. I don't know that we need like yet another AI agent framework to solve these problems for us, would be my sort of immediate assertion, but I could be wrong. Yeah, it could be wrong.
Yeah, and we do use a bunch of frameworks in this course, but also we do encourage people to start off by using API calls and vanilla Python and then adopting mindfully when there's code that they don't want to think about and don't want to write.
Yeah,
essentially.
Exactly.
Now for a word from our sponsor, which is, well, me. I teach a course called Building AI-Powered Software for data scientists and software engineers with my friend and colleague Stefan Krautchik, who works on Agentforce and AI agent infrastructure at Salesforce. It's designed for people who want to go beyond prototypes and actually ship AI-powered systems. The link's in the show notes. Brad has a great question. He says, please unpack harness engineering. I want to step back even a bit more. I did a podcast that we put out last week with Lance from Langchain, where we had a really nice conversation around what an agent harness is. But if you Google agent harness at the moment, it doesn't turn up. Like it turns up a tweet by you. So I am interested if you could step back. And could you first tell us, what is an agent harness?
I mean, agent harness is essentially the tools and capabilities you give the agent access to. So for example, can your agent spawn some agents? Yes or no? Can your agent write code? Yes or no? Can your agent write to and read from a file system? Yes or no? Can your agent use the file system as a scratch pad for planning purposes? Yes or no? Can the agent, then also like use search tools, all the different tools that you can imagine give it access to, more like kind of APIs, right? So this is ultimately kind of the agent harness. It's not just the model, right? It's actually like these systems gardening. It's the context in which the model sits. And it does really matter. It changes the capabilities of that model, and it can really change the utility and reliability of the system that you built as a result. And so I'll give you one example that we've seen, sort of a piece of the upcoming technical report that we're working on, is we've noticed that there's been some discussion on the internet about, I think it was from Cloudflare, talking about code mode, where they're like, oh, agents are better if they write code. And their thesis was because like, oh, it's because the agents are like very trained on code. And so it's like code maximalism thing. What we found is actually that's not the core reason. The core reason is that like when agents write code, as that artifact enables them to be more creative of how they blend tools together. And we get more creative about how they like, oh, I'm going to import date. The user asked me about what happened on a Monday. So like I need to first import date time to figure out like what days were Mondays. And then I can go and then search by date over here. And then again, they just get like you see some sort of emergent capabilities, the agent like thinking through multi-hop reasoning. And it seems like code is a useful scaffold on which to enable creative composition of tools together. And that's why we think that like code is useful for this. And again, it's if you just use the Anthropic API, the Open API directly, you wouldn't have that capability. It's because you put it in this harness of giving it access to other things. Just touch on like sub-agents really quickly. Like sub-agents are a really powerful way of managing context rot and distraction. Okay, great. And sub-agents, I think today are not mutually agreed upon as a best practice, but like my strong suspicion is that like in less than 6 months, we will start to embrace and admit to some degree that there are different classes of inference workloads that demand different types of inference. And that actually, for that reason, it makes sense to use sub-agents.
Totally. And so I actually brought this up before you mentioned sub-agents. This is from, but Anthropic's post from June, how we build our multi-agent research system. And I did want to bring it up because it has their lead orchestrator, then their search sub-agents, memory, citations, that type of stuff. And actually spawn sub-agents, right? They also have a process diagram, which I don't necessarily want to go into the details of, but when you started talking about what an agent harness is, I'm wondering if these types of diagrams are kind of ways to start thinking about what it would be.
Yeah, I think so. The text is a little small, but it does look somewhat relevant. Yes, exactly. And yeah, I'd also say that like the same day that I believe this post came out, Cognition published, I believe, if I recall, a technical blog post as well. And the title of that was like, why you should not use multi-agent design when building an agent. And both of those came out in the same day or within the same day, I think points to still how early a lot of this stuff is. Now, I think that like things have evolved and gotten more clear in the last many months since that came out. But I guess my macro point is that I don't think that everybody has embraced sub-agents yet, but I think they will.
Yeah, and I want to make several points there. I totally agree. And Anthropic's an interesting case because it was December last year that they were the ones who were like, hey, let's not necessarily go and build agents immediately. Let's look at workflows first and let's see how people use Claude and these types of things and how much you can achieve. So they were publicly quite mindful around this. And so when this blog post dropped, I was like, oh, they're finding utility from it. Also, like a lot of the points, there's a lot of complexity introduced, but like going down to having gold data sets and how much lift you get by looking at your data. Actually, one thing they noticed when you first look at what the sub-agents are doing, they're finding copy from heavily optimized, SEO optimized posts, and they just keep doing that. Whereas if you and a human look at that immediately, you can correct those failure modes. So even down to the evaluation and look at your data, the iterating on prompts, getting them to iterate on their own prompts as well. I didn't necessarily think that's something that would come out of it. But yeah, there's lots of interesting stuff that seems potentially pretty valuable.
Yeah, I think the search stuff and the deep research stuff using sub-agents in search is all still very early and embryonic. There was this like tweet that I saw, I can't quite ever dig it up again, but the tweet was something to the effect of, I used deep research for something that I know a lot about, and it wasn't very good. So I decided to use it for everything else instead, which I think is, to your point of like, the agents pay too much attention to the SEO bait is 100% true.
Totally. So we've got a sense of what an agent harness is, and what would be involved in harness engineering then?
It's a good question. I mean, I don't fully know. Like it might be that like everybody gives their agent the same 4 tools. And then that's all the harness engineering ever is. It's not like more than that, but it's not that every use case has its own special blend of harnesses or whatever. I'm not sure yet, but I think that obviously people will continue to like try to push these LLMs to further and further degrees of reliability, and then also more and more difficult use cases, like applying more and more of these tricks, you could call them, will become relevant. So we'll see if we discover a few more, whether or not, again, all applications will just really adopt the same set, or whether it will vary based on the use case. I don't know. I actually would lead more towards the former, not the latter. So I feel like really all use cases are going to use the same 4. So maybe there won't be like much engineering involved other than like copy and pasting the list. But
Wilma has a question. How will Chroma evolve to support very large context windows while avoiding rot? And she's thinking, e.g., 1 million tokens. I will also give you an out to say, maybe we shouldn't be wanting to put that many tokens in. But yeah, how do you think about this at Chroma?
Is the question like when context windows can support 1 million tokens, what will Chroma do? Or what was the question?
Yeah. Or how will Chroma evolve to support these types of things? Yeah.
I think, first of all, we don't ever know whether it's possible, whether LLMs in their current instantiation or future will be able to support 1 million token context windows accurately. Today, they don't. So that's the first thing. I would say, like, even if they do, there's always going to be like speed and cost advantages. If you've ever tried to use Gemini with 2 million tokens, it's pretty cool to like dump that much information into context. But like, you do wait for 2 minutes to get it back. And it does cost like over $1 per query or something like that. I think it's pretty expensive. And so if you're building a script for yourself, you might not care about that, right? You might be totally happy to spend a couple bucks and wait a few minutes for perfect accuracy, if it has perfect accuracy. But obviously, if you're building something that like touches end users and you have the mandate and the ability to save 90% of your bill and make the application 90% faster for end users, you will. And in our view, like, context engineering will always be relevant because your system will be faster and cheaper at a minimum by focusing the context. And I would bet that also more accurate. I don't think that, again, we don't yet know a solution to context rot. So it may exist in the same way that artificial superintelligence exists, or it may exist in the same way that aliens exist. We don't have any evidence to that account yet.
Yeah, makes sense. And so just for a bit more context, of course, context rot is when we have really large context windows and we're being told needle in a haystack is something which frontier models are very good at. And yet there are many other very simple things which don't work with these large context windows and actually degrade really quickly as a function of increasing context, the amount of context you put in. And I'm just going to bring up a figure of yours, if you don't mind me screen quoting you, for lack of a better term.
Yeah.
Okay. Yeah. Let's look at this one. So could you just tell us a bit what's happening here?
Yeah, so in this case, we are measuring the performance of different LLMs. You can see the legend in the top right at different input lengths, so the number of tokens. And of course, 10 to the 2 is 100, 10 to the 3 is 1,000, 10 to the 4 is 10,000. And the vertical axis is important to pay attention to here. So it's not 0 to 1, it's 0 to 0.5. But still, we see like a uniform degradation of this task called repeated words across the sweep of state-of-the-art models, at least at the time that we ran the task. And there's no reason to believe this change with state-of-the-art models. We'd like to run the benchmark on those as well. And you can see, again, a degradation of performance as the input length goes up. Now, this task, I will sort of nuance, is contrived. And so the way this task works is you give the model an input, which is a sequence of words, and then you ask the model to repeat back to you that exact sequence of words. So it could be 500 goldfish followed by 2 trout followed by 500 goldfish, just like that. And you see if the model can do it. Now, of course, that's really contrived. You're never going to have probably a real world task that is quite like that. But the reason this task is interesting is because it does, in some ways, measure the ability of the model to pay close attention to every single token of its input context. And the reasoning power, very low. You're just repeating the same word over and over again. That's fine, right? But the attention power required is very high. And of course, your tasks are not going to be quite like this, but your tasks might have another version of like high attention, which is required to achieve your task. And so again, these drop-off curves at a minimum complicate the narrative of, as you mentioned before, needle in a haystack, implying that the context windows are perfect. And that is just like certainly not the case.
Yeah, and so to your point that this is like a very simplified example if that, of what happens in reality is actually the most startling. And you speak to this in your report, but one of the most startling aspects to me, like all the things you test in it, we see context rot in, and these aren't even the things that we really build, right? Or the things that we need or want these systems to do.
Yeah. Context rot is like an engineering reality of these systems today. And we did that technical report without any recommendation of a solution because we felt that it was important that it was like standalone artifact, like demonstrating the problem, and it was not misinterpreted as us trying to sell anything. We do think that like it is likely that obviously search and retrieval are important tools in focusing and finding the right information. And a lot of our customers use Chroma's tools to solve those kinds of problems. But again, we did not put any selling into the actual technical report because again, we wanted to make sure that our intentions were clear. Our intentions were like genuinely, let's try to figure out what is the truth today, and the attempt to try to help builders build more quickly and easily with kind of what is currently capable of. And it was interesting to see how fast that technical report spread once we released it. So I think that every builder who's built in the space immediately said, "Oh yeah, that's definitely a thing that I felt plus one." So
absolutely, you did the best thing to sell in the end, which is to help people for free.
Sure, that's open source.
It is, and in the knowledge of everything you've discovered on context rot and everything we've all discovered since, I'm wondering if you could just talk us through for builders today in the course, just what are some emerging best practices for context engineering?
Yeah, I was just in a meeting live here in our office talking with some folks in the whiteboard behind me, and it's blurred so you can't see it, but I'm laughing to myself that it's right there. A few things. Number one, hybrid search I think is really, again, as I mentioned, a great default out of the box. So using lexical plus semantic search, BM25 plus vector search is a really great idea for most use cases. Having a golden data set, you got to have it. It's not as hard as it sounds. You can use an LLM to generate the queries for your chunks. It's a great starting spot. Number three, I think clustering is a really powerful tool that people like don't use as much as they should. So like looking at your agent traces and clustering them using embeddings is a great way to find patterns in your data. And like ultimately, that's the right way to debug and improve AI applications is not so much to focus over index on individual traces, but find patterns in your traces that you can extrapolate lessons and then apply that back to the agent to improve that. So yes, look at your data, use clustering to look at your data is very important. Increasingly, again, sub-agents, I think, are becoming a best practice. Giving your agent the tools that it needs to find the information that it needs. One tool might be just a search tool that uses hybrid search, but you may also want to complement that with a tool called getDocument, where the AI can give, the LLM can give you a path to a given file, and then either you go and grab that off of S3 directly, or you use it as a metadata filter inside of Chroma and just get all the chunks and put them back together out of Chroma. There's a variety of these like search tools, and again, we find that like the agents start to get more creative when they have not too many, but also not too few search tools. And when their descriptions are also very clear about like when and how they should use them, they get very good at using these tools. And so, yeah, that kind of like, I won't invent tools engineering here on the call, but like that kind of tools engineering is like increasingly an interesting point of like leverage as well. And then lastly, I think that I already mentioned the sub-agents piece, so we won't touch on that again.
Awesome. I'm glad you meant clustering and looking at your data as well. Actually, in the last cohort, I'll link to this. I actually wrote a blog post with him on it. Ivan Leo from Manus come and talk about Cura, so he's worked on Cura with Jason, who you also know.
Also know Jason,
which part of that project is really to be able to cluster and visualize and get a sense of what's happening at scale in your agent conversations. And of course, both of their like laser focus is on actual like shipping really good product. And as it should be. Yep. I am wondering how you think about evaluation of context engineering, or do you do that more broadly when you think about evaluation of retrieval?
It's a really good question. I think measuring the performance, measuring single stage search performance is pretty well understood. Again, you need a golden data set, you need given this query, it should return this chunk, and then you need a bunch of those. And then you can try different search strategies. You can do different embedding models, different types of search, add BM25, add re-rankers, add query expansion, blah, 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 blah. Like deterministically evaluate and iterate the system. I think everybody intuitively understands that search performance should affect agent performance. Better search means better agents. Everybody gets that intuitively. Now the question is how and when and why and where. And also if we're figuring out that certain errors or omissions or bugs are in our current kind of end-to-end agent trajectories, to what degree is like the search either a contributing factor, or how can we iterate the search to improve and solve some of those problems? Honestly, the jury is very much out on that right now. Like we talked to a lot of customers about how they're doing agentic evals. And these people that I talk to, a bunch of people here in Silicon Valley, like they don't really have an answer. You'd think that there'd be an answer to this because there's $1 billion plus of venture capital that's been poured into like agent observability startups. But it still seems that, at least if we're talking to, that like nobody really has it like figured out. LLM is judged not really a panacea per se, useful, but not a panacea. Labeling data is obviously very expensive and time consuming. Also brittle because your system changes. You change one tool and all of a sudden, is all that label data worth it anymore? Is it worthless? I don't know. It's like, we'll admit that this is like an unsolved problem and probably not a problem we narrowly are going to solve at Chroma, because it really seems like it's more of a industry-wide problem versus like search and retrieval focus. But we do care about it because obviously we want to help our customers understand, as your search goes up, how much better does your agent get? And so we do care about it for that reason. But
yeah, totally. And it is highly unsolved and slightly, maybe just slightly existential in some ways. I think, depending on how far we go with agents. Brian Bischoff at Theory, who was at Hex and several other places beforehand, he has a nice way of thinking about it. And it doesn't come without its challenges, but he has a great talk called Failure as a Funnel. And he actually thinks about transition matrices between steps and populating failure mode, that transition matrix. And you need a lot of data, and you looking at your data and that type of stuff, but you can see where your highest leverage points of pulling levers to fix things can emerge there.
Yeah. I mean, I think that one of the big changes is software engineers are used to not really looking at their logs unless they absolutely have to. And they're used to their logs telling them exactly more or less what's at least broken, not necessarily how to fix it, but what's broken. And I think your agent observability story is much different, where like you look at logs even more, but the logs aren't going to tell you if it's broken or not. And they definitely won't tell you how to fix it either. And looking at your data is really important. I've gotten the pitch from Brian directly before about the step waterfall evals. And I think that makes sense for workflows that are highly and tightly defined. So if you're doing a text SQL agent, you, again, break it into each individual column. Did you get the right tables? Yes or no? Did you get the right columns? Yes or no? Did you write the join? Did you figure out the right joins? Yes or no? Did you write the SQL correctly? Yes or no? That makes sense. And like, I think if you want to get a certain level of production reliability today, you do need to break specific tools into like very specific, highly iterated on and highly controlled workflows. That being said, intuitively, I think people are not wrong to want to just give it to the model and let it figure it out. And I'm not really an AGI maximalist, but like, I do think that like text to SQL will probably be genuinely eventually solved by AI models. And maybe you'll be able to get from like 99.9 reliability to 99.99 reliability by embracing kind of a waterfall style approach to measuring the evals and stuff, right? Which for some use cases might matter, but I think for the vast majority of use cases, eventually the next 9 of reliability is not worth the cost.
Yeah, and to your point, in some more constrained situations, it could be very valuable. But if we have sub-agents spawning sub-agents, there are limits there as well. There's the inner loop of how we fill context now, right? Which is one part of context engineering, but how should we think about the outer loop of long-term improvement of our context selection strategies?
Yeah, I think this is ultimately the real job of context engineering. One is like setting it up for the first time. And like you create all the pipes, you create all the connectors, and you make sure the agent can use them correctly. The data starts flowing, and that's great. And that's going to get you somewhere, right? Let's say they get you to 90% reliability. If it's an internal use case, that might be fine, right? 99 out of 10, good enough. Use the agent, use the human. You're already an expert. When it fails, you just click retry and maybe you'll get the next time, right? 9 out of 10 might be fine for some use cases, but for use cases that are non-subject matter expert facing, either internal or to like end users and customers, like your brand is very much on the line, right? Your brand has to live up to a certain bar of reliability and accuracy. 90% is not enough. You need to get to like 99.9, etc. And I think there's both the system, there's the machine, and then there's the machine that builds the machines. And people are building an AI today. We're very focused on building the machine. We're not yet focused on building the machine that builds the machines. But I think this will, over time, can change, where like people will think less about the pipes required to set it up for the first time. That'll happen largely very quickly and automatically. And they'll think more about what are the systems that allow my agent to get better over time, right? It's both figuring out what do I put into context this time? That's the inner loop. And then it's how do I get better at context filling over time? And that is the outer loop. And there's a few people now starting to talk about like memory. Usually it's like the context of remember my dog's name is blah. Remember I like to eat this. It's kind of these cute little like user memories. That's fine. But over time, again, we intuitively want to build agents where we as humans can give those agents feedback or the environment the agent is operating in, can receive feedback from the environment, and then can self-improve. And it's not recursive, fast takeoff, gray goo, paperclip the universe style, we're all dead now, fast recursive self-improvement. It's just basic stuff, right? Oh, if the user wants me to add an image to the Next.js app, I should put it in the public folder because that's what the user named it for this app. Or just like basic stuff, right? That again allows the agent to do its job better and do it faster. And again, we're both growing the plant, but also designing the garden in which that plant operates. So.
Yeah, I really like that analogy. I am also interested when I spoke with Lance about a lot of this stuff, he mentioned two things. He reminded me that Manus has rebuilt their product 5 times since March or something like that as new models come out. And he also mentioned that Claude Code is whatever, a lot of it is harness, but then when there are new models, they rip out and rebuild the whole harness. And so this seems, just because of the new competence, this really seems once again like an even further new paradigm of what it means to build software. So I'm interested in your thoughts on how we ship and reship and re-architect.
Yeah, it's a good question. We as software engineers are not too used to this change. Maybe if you're a software engineer 40 years ago, you were used to like architectures changing underneath you and you having to change your software. But obviously, people that have been doing mostly like web dev and cloud dev in the last 20 years, it was a pretty good time in terms of things not changing underneath you all the time, or not having to change underneath you all the time, at least. I think the big trend is that the model providers all now have large sources of data collection, whether that be their coding tools or their consumer-facing tools. They obviously have their existing agent harnesses where they have all these like tools the agent has access to, skills in the Cloud Code universe now. And then they are naturally using all of that data of the usage of these tools to fold those kinds of capabilities back into the model itself, which then oftentimes allows you to remove kind of hard-coded stuff. And by removing hard-coded stuff, you increase the expressiveness and creativeness of the model. And so if you want to be on the state of the art, the cusp of the most advanced consumer AI experience, then like you very much have to do that. People are always wowed by like these new consumer demos of booking me a flight or planning a whole trip, or it always seems to be trip planning for whatever reason, even though that's a dumb use case for AI in my opinion. But people seem to always love those demos, doing my taxes, I don't know. And so I think certainly if you want to compete at the forefront of consumer AI, then like you probably should be re-engineering, re-architecting your system every 6 months to account for the change in models. But I think the reality for most people building is that's not what they're building. They're building something for a very specific use case, for a very specific customer, with a very predefined set of workflows and tools. And again, that customer doesn't care if it can if the AI can do the taxes while doing underwater basket weaving at the same time. While it's a really cool demo, if you're like a consumer, you just want to do your taxes. Like you don't care about like these, wow, I can do both at the same time and it can interleave them together. Who cares? So yeah, I don't think this is a huge risk for builders as much as people like make it out to be. I think that this is arguably more, you always have to be skeptical of what the language model labs are telling you about the progress of AI. So, oh my gosh, it's so fast. The new stuff every week. The future's changing so fast. Fast takeoff, AI, AGI, PhD, blah, 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 blah. You can't stop. You can't go on Twitter and not see the propaganda. And I mean, listen, if I needed to raise $100 billion, I'd be saying very much the same thing. Absolutely.
It is a relatively straightforward act of debiasing if you take someone's incentives, what you know of their incentives, especially when there's worth that amount of money into perspective. So that actually brings me to a question I wanted to ask. There's just so much noise in the space. How do you decide what to focus on, and how would you encourage students in this course who are building decide what to focus on?
That's a good question. And increasingly, I'm following academics versus people in industry. They end up having to be much more measured just because of the pressures of the game that they're playing, right? They can't be too insane or hyperbolic in their research papers. So like finding some really high quality Twitter accounts that like curate great research, or just like following great researchers. You can also obviously do your own research, pun intended, and go investigate given topics in depth on AI applied to X or Y or whatever. So, that's not as entertaining as following some like AI hype beasts on Twitter who find a way to use 10 head exploding emojis in every single post. But I think it gives you a much closer sense, ear to the ground, of what's possible now, what will be possible in the future. And if you're a builder, I would argue that's what you really care about. It's not the craziest demo from somebody else. There are some exceptions, I suppose. Like video models seem to be like very much on the steep curve right now, versus language models, I don't think are getting like dramatically better every model release, versus video models just, oh my gosh, mind-bendingly better every model release. Image models as well, right? With Nano Banana and everything else. If you're talking about other kinds of AI, maybe it's a little bit different. But yeah, I think academic is a good place to look. Academia, you can see who I follow on Twitter if you want to get a sense of that. Don't follow the AI hype beast, not worth your time. That's about it. I'll plug AI News from Sean Wang Swix. I think is a good publication.
That's great.
Check that one out.
And finally, got to wrap up in a minute. Are you hiring at the moment, or is there anything you want to plug about what you're up to or what people should look at with respect to Chroma?
People should absolutely, I think we'll hand out some credits here as a part of this. And so, definitely give Chroma a spin and try it out with BM25, try it out with semantic search, try it out as hybrid search capabilities. Chroma's by far the fastest, cheapest, easiest to use thing out there. And we love what we've made and we'd love your feedback on how we can make it better. In terms of hiring, we are hiring very good backend engineers and infrastructure engineers, cloud engineers here in SF. So if you're local or you want to be local, if you're Australian, I think there's a pretty good visa situation to move to the US and do that. So you can reach me, you can DM me on Twitter, or my email is just jeff@trichroma.com. And I would love to hear from you.
Amazing. Thank you so much for sharing your time and wisdom and just all the cool ideas about what you're thinking about and working on at the moment, and for all the credits for people to build with as well. Really appreciate it, man.
Thanks for having me, and thanks for putting together a great course.
Awesome. And everyone's saying thank you in the Discord. Awesome. And scene. Thanks for tuning in, everybody. And thanks for sticking around until the end of the episode. I would honestly love to hear from you about what resonates with you in the show, what doesn't, and anybody you'd like to hear me speak with, along with topics you'd like to hear more about. The best way to let me know is currently on LinkedIn, and I'll put my profile in the show notes. Thanks once again, and see you in the next episode.